platform, you'll see that there will be, just before we get going, we'll just like to know that there is some new GoToWebinar interface on the right-hand side. We won't be using any webcam for this particular webinar, but there will be a poll that I'll go through a bit later, and you'll also see some applicable handouts for this webinar on the right-hand side, and you'll also be able to chat with us. So during the webinar, if you have any applicable questions that you want to ask, or then just feel free to type that in the chat on the right-hand side, and we'll get to that at the end. So just an introduction about myself. I'm the industry manager for mining based in Sydney, Australia, and I've been with Endress+Hauser for 3 years now. Previously was from a processing optimization role with a large Australian mining company, and I'm glad to bring some of that knowledge back to this role with Endress+Hauser. So for those that might not be familiar with what Endress+Hauser is as a business, I'll just give you a brief overview. So last year we had a net sales of over 2.6 billion euros, and we have more than 14,300 employees worldwide. So we're a solid, reliable instrumentation supplier across the global stage. We invest heavily into our R&D and innovation processes. So you can see we've got more than 8,000 patents and patent applications worldwide. We have a wide industry-focused product offering as well, particularly in mining, but also in our other focus industries. We have a diverse service offerings available. So for example, we have offerings in all phases of the plant life cycle, and we're also your partner with various automation solution offerings such as transfer, storage, and distribution, compliance, and lifecycle asset management systems. On the right-hand side, you'll see just some of the different portfolios that we have devices in. So level, pressure, flow, temperature, liquid, analytical, and then we also have some other special parameters and software and system products as well. So again, everyone that's joined now, welcome. And our agenda for today, I'll just be going through introduction into flotation as a process, the benefits of additional measuring points on flotation applications, our recommended devices for each of our main measuring points, and then some questions as well at the end. So again, if you just joined us, feel free to type in some of the questions on the chat as we go. So flotation is an essential sub-process in mining. Many plants use flotation as a way to separate the valuable minerals from the unwanted gangue material. And on the left-hand side, you can see a general overview of the mining process. And in that pink box there, that's the flotation beneficiation stage. So Endress+Hauser have a great portfolio across all the mining processes, but we'll just focus on froth flotation today. So as I mentioned, flotation is a physical and chemical beneficiation process where particles are separated on the basis of their surface properties. So that means in general, valuable minerals are rendered hydrophobic, which means they don't like water. And then the unwanted reject materials are what we call hydrophilic, which are water loving. On the right-hand side here, you see the different measuring points that we recommend on a flotation cell. So whether it's level, flow, Q, which is quality parameter. So in this example, it's pH, but we'll also talk about redox later on, and D for density. So in a flotation cell, it's not good enough just to have the best control system that you can get, but you also need reliable information from the field and robust measurement equipment in the plant. So we help you optimize your process via our reliable instrumentation and the advanced diagnostics that the instrumentation gives. So for example, level measurement in your flotation cell, that's very important to make sure that the performance is maximized. We can get information around the pulp density of the flotation cell, and that's critical to the flotation kinetics and selectivity of the valuable materials that you're floating. Smaller bubbles help the flotation process as well. So whether we're measuring the different frothers or additives that are going into the flotation cell, or if we're calculating the gas holdup as well. Other chemicals such as collector, that dosage is critical. So an underdose can cause recovery shortfall, or an overdose slows down the flotation and impairs the selectivity of the valuable materials as well. So these are the devices that we recommend on each of these points. Now, before I go into each of the specific measuring points, I'm just going to be asking everyone a question that they might have. So this should turn up on your screen now. On your site, do you have any type of advanced control on your flotation circuit? So whether you have advanced process control or model predictive control. If you're on site already, then you can click yes or no, or if you're planning to implement some type of advanced process control in the future. Otherwise, if it's not applicable, then just type non-applicable. But it's been quite curious to see some of the results from other customers, and we know a lot of people are planning it for the future because obviously that is where the money is being made in terms of yield on most of our mining sites. So, all right, so I think most people have voted now, so I'll just close the poll now. And now we should be able to see the results. So a quarter of you said yes, you already have some type of advanced process control. And then another majority said, 15% said they're going to be planning it for the future. So this is definitely relevant for you. And then 8% said no, and then about half of you not applicable. Okay, so this webinar I think will be great for you guys, even if you do have some type of advanced process control existing already on your flotation circuit. You can just double check that you have the information going into that control system is as accurate and robust as possible. So the first step for flotation is the feed characteristic. So there's a number of different variables that are measured if you want to implement a feed forward control in the future. You need that feed information, and whether that's density, flow, mass flow as well, or turbidity, there's a range of devices that we recommend. So mass flow requires a electromagnetic flow meter, so the ProMag 55S, and this is coupled with a FMG 60 or FMG 50, which is our radiometric density detector. ProMag 55S has natural rubber liners and robust electrodes specifically designed for these range of slurries that are going in there. And you can see on the right hand side, this is the setup that we've been quite successful in determining the mass flow of flotation feed. And on the left hand side, some customers prefer to measure solid suspended, particularly if the solids loading is quite low in the flotation feed. Around that 3 to 5% mark, and we can use the colored 50D there for measuring the solids suspended, and it can be used alternatively. So this is our new device, which is particularly been designed for heavy industrial applications. And you can see the novel design of the head there on the left hand side, and it minimizes fouling. Now, an alternative to this as well that we've been quite successful in is implementing a vibronic fork into a flotation feed. So this example here is an iron ore flotation. So you can see the process information on the right hand side there and the installation of the picture on the bottom right. And the typical installation of the pipeline of the vibronic fork is just to make sure that it's out of the mainstream, just to minimize any localized wear on that area. And in South America, we've been quite successful in implementing this, so that might be a consideration for you if you require to go down the non-nuclear path for density. I'll move on to the level of foam and pulp as well in flotation cells. So what we've found that's worked best on flotation cells is utilizing an ultrasonic device that measures the top of the foam and also measures the top of a metal target, which is connected to a ball float. So you can see this arrangement on the right hand side, and that ball float floats on the top of the pulp, so it's underneath the foam, and that gives the level of the pulp. So the conical shape of this float in this example minimizes the buildup of any concentrate that's on top, and the density of the ball float is also just slightly above pulp density as well, so that you can make sure that that float doesn't get stuck and it's always floating just on that pulp level there. There's a guide rod as well, so the rod doesn't get dislodged, and we've found that to be the most accurate and robust way to measure level. There's other options that have been used. So for example, in the tall column flotation cells, as particularly the older ones, they've used pressure and differential pressure as well. We've found that they're not necessarily as accurate, especially as the feed density can change. But the advantage there using differential pressure is that you can determine air fraction or gas holdup proportion, and that is possible. And that is additional information to determine the particles, the bubble size, because gas holdup fraction is related to that if the area is fixed. So if we have an accurate level device in this example, then we can go towards tuning the level of the flotation cell more accurately using P&ID feedback. I guess the next step after that is to install smart positioners to ensure that the valve is opening as minutely as possible in relation to the P&ID feedback control. Then we've seen sites implement a feed forward control loop depending on the feed information that they're getting. They've managed to minimize any disturbances in the surge shank to control that tuning as well. Then using froth velocity controller or froth cam, then they've optimized the level of their cells all the way, resulting in best practice on maximizing the value of the minerals that they're getting out of their flotation system. But the point here I want to emphasize is that it all resolves around the accurate and robust level device at the beginning. Management of pH and ORP sensors on sites has been a challenge for a very long time, and a lot of the sites it is still a challenge. But we've specifically designed CPF81D, which is our pH sensor, and our CPF82D, which is our redox sensor for these applications. So the flat shape of the glass membrane is less affected by abrasive materials. We've got a PTFE diagram, which prevents blockage by these the slurry particles, and also the enclosure around the device makes it virtually unbreakable, which is great in a harsh mining environment. This is some examples of our pH sensor in flotation cell. So as long as the probes are looked after and they're cleaned with water and some weak acid as well every 2 to 4 weeks, then we've seen over other devices a benefit of time saving and accuracy, because we can calibrate these devices offline and increase the sensor lifetime as well by more than 6 months. Now I'm going to be talking about the difference and the value, I guess, of MemoSense, which is our digital protocol, against our analog devices. So Bayer Technology Services have made a report around the benefits of digital protocols, particularly MemoSense here versus our other analog systems. And even though the additional capex of MemoSense is larger than an analog device, the OPEX is greatly reduced there, because as you can see, it is the years of operation go ahead. And the reason why that is because it takes less time to maintain these devices. You consume less of these sensors over its lifetime because you're calibrating them in the lab, and you're also rejuvenating these devices, and you have less costs in cable replacement as your lifetime goes on. If you want to further optimize your pH measurement, then we do have additional options as well, depending on if it's suitable for your installation. But we have a liquid line control CDC90. This is a automated calibration and cleaning tool, which if your process requires accurate, reproducible, and measured values that are available 24/7, or if your sensor needs to be cleaned and calibrated very frequently, so in very harsh environments, or alternatively, if your measuring point is really difficult to access, or it's located in a hazardous environment and you want to minimize the time spent maintaining those devices out in the field, or it can't be properly serviced manually, then this is definitely an option for you. And it has many benefits, including improving your safety because you're reducing your hazard exposure in the plant, seamlessly can integrate into your system digitally, and also there's less maintenance effort. So now I'm going to talk about air control for flotation cells. So moving away from manual control and those manual hand valves that we see around some of the older plants towards optimization. So it's common that there might be one air supply for 2 or more flotation cells with manual control in between, which is really judged by operators visually looking at these cells. And this, by their inherent design, can give some issues. So whether the air supply blockages that aren't picked up, whether there's uneven levels or uneven airflow between cells, this is not ideal from a yield perspective. And we've worked with a number of customers to update this so that they have individual airflow control to each cell, and it's measured and controlled with engineering units rather than just a visual observation by operators. So this is an example of metering. So we can use the Vortex Meter, which is compact and fits easily in a confined space. You can see a picture here. We know that plants vibrate, and there's harsh environments as well. So it's very insensitive to that, while offering a high accuracy. And there's also integrated diagnostics with the device as well, so that you can continuously monitor any sensor errors that might be caused by contaminated air or rags in the airline or whatever might happen in the plant. There's also a comparison to a thermal mass meter. So the attraction of this is the improved turn down ratio. So it can measure at low flow rates when the Vortex meter will read 0, as the vortices are not created when the Reynolds number is too low. So that's the low flow. It's hardly any pressure drop as well, and you can measure meters cubed per hour directly without the requirement of a pressure or a temperature transmitter as well. So the cost of the thermal mass meters are higher than Vortex meters, but these advantages alone far exceed the difference in cost, and we're seeing a ratio of around 85% selling thermal mass meters to about 15% of thermal meters now. So the best practice is definitely the thermal mass flow meters at the moment. Now, I spoke about the importance of collector and frother in flotation cells, and I'm sure you're all aware of the importance here. But have you got the most accurate meter on your site for dosing of additives for your flotation process? So the most accurate meter we have, and that's available on the market as well, is a Coriolis mass meter. So the accuracy of up to plus or minus 0.05% ensures that none of any reagents get wasted or unevenly distributed to the cell, so you reduce your overall reagent cost, and you'll also make sure that you maximize your yield of your cells. Of course, these devices are insensitive to plant vibration, and it's also independent of any temperature variations that might occur during the day. So you don't get those issues where night shift is performing much better than day shift because of those temperature shifts on your flotation circuits. And of course, if you want to manage your inventory of reagents and chemicals, then you can talk to us as well, because we have a solution for that as well. So this is an example of how your highest precision and accurate device we can tune, or you can tune with more advanced process control to maximize your best yield from your flotation circuit. So from your flow control and tuning to doing ratio control of so relating that back to your feed, all the way to feed forward control, changing your strategies for startup and shutdown, optimize your MET control, and then in the end, lower your reagent cost and maximize your yield. So now I'm going to ask one more poll. So she could come up on the screen now after I've gone through a whirlwind of going through some of the best practices devices on your measuring points. So seeing all that, are you happy with the current level of data that you're getting from your flotation circuit, from your instrumentation? And these are just the major points as well. Obviously, there's a lot of other information that we can get, whether your flotation cells have recycle streams where you need pressure sensors, or there's information on your tailings, perhaps percent solids or feed and other things like that. So I'm just collecting the responses there. All right, 2 more seconds. Okay. All right, so I'll share it with you. A third of you are happy with the current level of data. About a quarter of you not happy, and then the rest of you not applicable. Okay, thank you everyone for your participation there. All right, I'll just go to the next slide. Okay, so where to from here? So we can guide you through the instrumentation selection process of your optimization project that you're going to be having on your site. And we work with many partners as well, including those that utilize model predictive control and advanced process control. So we can talk with them, we can partner with you, and then we can make sure that we're offering the most innovative and reliable instrumentation for your process. We can also help you develop any IoT solutions with your project as well. So we have partners as well that can help you with IoT dashboards or optimization, or incorporating that big data into your optimization project. And of course, we can support you with any service contracts available to maximize your availability of your plant as well. All right, thanks for your attention there. I'll just go through some of the questions now that we've got. So again, if you've got questions, just type it in the chat on the right-hand side there. And now I'll just go through some of the questions, just having a look. All right. One of the questions we've got is, why can't we use our 80 gigahertz radar to measure foam and slurry in flotation? Okay, yep, so that's a really good question. So if you're familiar with the rest of our range, we know that level devices can detect foam, which is our free space radar device, but unfortunately it can't detect how much foam. So this is using a technology called heartbeat, and it uses the area of uncoupling, which means that the signal gets processed back by the electronics, and we can detect that there is an interference there, in this case foam, of the signal, but we can't detect exactly how much. So that's the case there. If you wanted to determine the level of foam in flotation, then definitely the best way is using the ultrasonic and the ball and float method. All right, so we've got one more question here. Can we use an electromagnetic flow meter instead of a Coriolis for feed. Okay, yep. So what's the difference in accuracy information of a return on investment of Coriolis versus mag meter? Okay, so I'm assuming that this would be in terms of flotation feed. In this case, if you wanted to use a Coriolis, the line size of flotation feed lines, particularly for the larger sites with tall flotation columns, like coal mines, for example, they can be quite large, maybe around 400 mils or so. And if you were to have a Coriolis that is this large for flow, then that would be very expensive. It is full of bubbles, so that the mass would be difficult to measure as well, but we do have a Coriolis that can detect air entrainment, but it doesn't go up to that line size. So in terms of a return on investment, it wouldn't be worth the additional cost of a Coriolis when you can just use a nuclear ionic measurement and also electronic magnetic flow meter. Another question we've got, how well does the ProMass measure the mass pull of froth coming off the cell? I think the question there was, how does a Coriolis meter determine the mass of a froth? At the moment, we're not entirely sure of that one, but we can definitely work with you guys to implement a trial at this stage if you want as well. So we'll get in touch with you. Another question, how do we calibrate the vibration-based density meter? Okay, so good question. This one comes calibrated from the factory, so we can do that, and we can also use a point calibration as well, where we can use the lab data to measure the density and then put it in the density computer. But we can send you some more information about that as well. All right, if there's any more questions, otherwise I'll just close the webinar for today. So thank you for joining, and make sure that you fill in the survey at the end of the webinar as well, and we can get back to you if you've got any more questions. For any that we missed today, we'll get back to you. Otherwise, thanks very much for joining, and we'll see you in the next webinar.